Welcome back to our PLC Servo Motor Position Control series. This is part 5. In part 4, we examined system behavior when the S-on enable signal was kept constantly on. Now, in this video, we will take that same system and configure it so that S-on remains permanently off. We will walk through the specific parameter configuration and explain how the system behaves under this condition in a live demonstration. Let us get started. First, the key components, all from ATO. A PLC, a servo drive, and a servo motor. A 3-button control station for clockwise, counterclockwise, and stop. An S-on enable button, and an emergency stop button. Plus, 3 interposing relays used for motion limits and alarm reset. This remains a pulse output-based PLC control system. The PLC sends pulse signals to control motor movement. The key difference, the drive is configured so that the enable signal is always inactive. Let's look at the actual setup. The control station connects to PLC inputs for direction and stop control. The e-stop also connects back to a PLC input, for example 0.07, for the software stop signal. Meanwhile, it's wired in series with the S-on enable button in a single junction box. This series circuit goes to pin 7 of the drive's CN3 connector. Finally, the PLC outputs pulse signals to the servo drive. Let's examine the detailed wiring diagram for this system. As you can see on the schematic, we highlight the exact wiring details for the start-stop station, the enable button, and the emergency stop button. Next, the diagram clearly highlights the wiring specifications for the PLC inputs and outputs. We also have a multi-core wire and plug number comparison chart. This table shows the wire colors and plug numbers for the CN3 signal cable. Different wire colors connect to different terminals. Next, the servo drive connections. Main power connects through L1 and L2. Control power uses L1C and L2C. The motor connects via U, V, W, and ground, and the encoder connects through CN4. Finally, the schematic shows the wiring for the 3 interposing relays, labeled as KA1, KA2, and KA3. Next, the servo drive configuration. First, set control mode to position control. Press M set, navigate to PN000. Press data. Change to N0010 for position control with pulse train references. Press and hold M set to save. Then move to parameter PN50A. Press data and set it to N2101. This enables configurable input signal allocation. Now the critical step. Change the value to N2181 to set the S-on signal to be always inactive. Press M set to confirm. Now PLC programming. Create a new project and select the appropriate device and CPU type. In the ladder logic, the e-stop is a normally closed contact, so the PLC sees it as on normally. Pressing CW sends a 20 kHz pulse train for clockwise motion. Pressing CCW sends pulses in reverse. Pressing stop stops the pulse output, bringing the motor to a controlled stop. If the emergency stop is triggered, all motion stops instantly. For the protective interposing relays, KA1 and KA2 enforce motion limits, cutting off movement when limits are reached. KA3 allows alarm reset when triggered. Now the core test. Turn on the power. The drive powers up. Press the S-on button. Nothing happens. The display does not show run. The S-on signal is always off. The parameter setting overrides the physical button. Only changing the parameter setting can restore normal operation. This demonstrates that without an active S-on signal, the servo system cannot operate, regardless of control input. This can be useful for safety lockout or maintenance situations. If you want to build this setup yourself, you can shop all these featured components right now on ATO.com. We offer robust programmable logic controllers, intelligent digital servo drives, precision servo motors, intermediate relays, and many more. Head over to ato.com right now to explore our vast catalog of diverse premium industrial automation solutions tailored exactly to your engineering specifications. If you found this guide helpful, please hit the like button and share this video with your engineering peers. Make sure to subscribe to our channel and leave a comment below with your thoughts. Thank you so much for watching, and we will see you in the next tutorial.